mathematics class. This class is for class 9th, and the chapter that we were doing was rectilinear figures. Few questions were left in that question, so today we will be doing those 2-3 questions which were left. So I have done in the previous class, we have done up to question number 20. Now question number 21 is already solved in the book. That is why I am not taking it up. In case anyone has any doubt, you can send it to me. I will be explaining you. You can send it to me on this number. I will be sending you the solution, or in case any doubt if you have, you can send your doubts to me on this number. Now, next question is 22. It is having two parts, so we will be discussing the first part. In the first part, I'll just read out the question. They say, in the figure given below, ABCD and ABEF are parallelograms. ABCD is a parallelogram. What is given? I'm writing here ABCD and ABEF. These two parallelograms are given. These are first and second parallelogram. Now, with the help of this diagram, you have to prove there are three parts. CDEF is a parallelogram. You have to prove that CDFE is a parallelogram. So you have to prove CDFE is a parallelogram. Second point, you have to prove that FD is equal to EC, and third point, you have to prove that AFD is triangle AFD is congruent to triangle BC. Now, we know that according to the properties of parallelogram, that in a parallelogram, opposite sides are one pair of opposite sides are parallel and equal. If it is given that ABCD is a parallelogram, we can say that AB is equal to CD and AB is parallel to CD. Why? Because ABCD is a parallelogram and that is given. Instead of this, you can even write given. Second point, ABEF is a parallelogram. So you can say AB is equal to EF and AB is parallel to EF. Now this time I am writing given. If you want, it can also be written that AB is a parallel. ABEF is a parallelogram. Now AB is equal to CD and AB is equal to EF. AB is equal to CD and AB is equal to EF. So from, let us say that this is our equation number 1 and this is our equation number 2. From equation number 1 and 2 we come to a conclusion that CD is equal to EF. CD is equal to something, EF is also equal to the same thing. So CD and EF will be equal. So I have written CD is equal to EF. At the same time, AB is parallel to CD or CD is parallel to AB and EF is also parallel to AB. So we can say that CD is parallel to EF. These are the results we drew from equations 1 and 2. We get these things we are getting from the above two equations. Now we have proved that CD is equal to EF. This is CD and EF are equal. At the same time, we have proved that CD is parallel to EF. CD and EF are parallel to each other. So you can see CDFE. In CDFE, we have proved that CD is equal to EF and CD is parallel to EF. If these two things have been proved, it means opposite pairs of this quadrilateral CDFE are parallel and equal. If they are parallel and equal, then we can say that CDFE is a parallelogram. So we will say, therefore, CDFE is a parallelogram. Why parallelogram? Because we know that if in any quadrilateral a pair of opposite sides is parallel as well as equal, then it is a parallelogram. So first thing we have proved that it is a parallelogram. Now we move, this was the first part. Now we move on to the second part. They say that prove that FD is equal to EC. FD and EC are equal. So when we consider, the second point is, if we consider CDFE, CDFE, since CDFE is a parallelogram. Why parallelogram? Proved above. We have just proved in the first part that CDFE is a parallelogram. Now FD and CE are the opposite sides of parallelogram CDFE. So we can say FD is equal to EC. Why? Because these are opposite sides of parallelogram. Which parallelogram? You can name it also CDFE. Therefore, these FD and EC are opposite sides, so they will be equal. This side and this side will be equal. Second part is also proved. Now we move on to the third part. In the third part, you have to prove AFD is equal to BC. So we will take triangles. In triangle AFD and triangle BEC, let us see what we have. In triangle AFD, we know this, okay. So we can say, in triangle AFD, we can say AD. This AD is equal to BC. Why they are equal? Because these are opposite sides of parallelogram. Which parallelogram? CDAB or ABCD. ABCD. Since AD and BC, this AD and this BC are opposite sides of parallelogram ABCD, and we know that opposite sides of the parallelogram are equal and parallel. So we have said that these two are equal. A reason is there. Now similarly we can say AF and BE. AF is equal to BE. Why? They are again opposite sides of parallelogram. Which parallelogram? ABEF. It is given already. ABEF. It is given that ABEF is a parallelogram. ABEF is a parallelogram. Now ABEF is a parallelogram, so opposite sides of this parallelogram AF and BE will be equal. So that is why AF is equal to BE. Third point, we can say that FD in triangle AFD and EC is equal to EC. Why? Just now we have proved above. We have proved that FD is equal to EC. That is why it is written FD is equal to EC. Proved above. So triangle AFD is congruent to triangle BEC by which rule? SSS or side rule. Hence this is also proved. So that is the proof of part A of question number 22. Now we move on to the part B. Now question number 22 B part. This is the second part or the B part. In this it is given that ABCD is a parallelogram. First thing, ABCD is a parallelogram, so I have drawn a parallelogram ABCD. Then ADEF is a square. It means all these four sides are equal. And ABHG are this is also a square. So AB is equal to BH is equal to GH is equal to AG. All the four sides of this square are equal. We have to prove FG something like this, and AC will be something diagonal of this parallelogram. So this is what we have to prove. So first of all, we'll draw the construction. What is our construction? Construction is join FG and AC. This is what we have to join, construct. So I am joining FG something like this, and AC. AC will be something like this. We have joined FG and AC. Now, FG and AC have been joined. So we have got two triangles FAG and ABC. To prove FG, this part is equal to AC, we need these two triangles, triangle 1 and triangle 2. So first of all, we will write which triangles we are considering. So to start with proof, we can say in triangle FAG and triangle ABC. Now what do we have in this? First of all, we can see this side is equal to this side, because whatever is FA same is AD, and whatever is AD same is BC. So FA will be equal to BC. Then FG will be equal to AB. Now what is left? Only this angle is left. So first of all, we need to find out this angle and this angle. Now this angle will be, if this total angle is A, means angle DAB can be simply written as angle A. DAB can be written as angle A. This is angle A. Now, we know that angle A plus angle B is equal to 180 degree because they are co-interior angles of the parallelogram. Angle A and angle B are co-interior angles of parallelogram. Co-interior angles, or you can say co-planar angles. So we can say that implies that angle B will be 180 minus angle A. This is required, very important. So this we will be leaving it here only. Now let's talk about this angle A. Since this angle is 90 degree because it is angle of a square, this angle is also 90 degree because it is the angle of a square, and angle DAB is angle A only. So if I can say, suppose I start with BAD, angle BAD, that is angle A, plus angle DAF, angle DAF plus angle FAG plus angle GAB. GAB is equal to 360 degree. Why? Because all these angles, first, second, third, fourth, all these four angles are being made around a point or on a point. So we know that angles, sum of all the angles made on a point is equal to 360. Now angle BAD is angle A plus angle DAF. DAF is 90 because it is the angle of a square, plus angle FAG. FAG we need to find out. Angle FAG plus angle GAB is again 90 degree. It is the angle of a square. So this is 360 degree. 90 and 90 is 180. 180 goes to that side, will become subtracted. So angle A plus angle FAG is equal to 360 minus 180, that is 180 degree. So angle FAG, I mean to say, exterior angle, this angle FAG, this exterior angle will be 180 minus angle A. And we have proved that angle B was also 180 minus A, and this is also 180 minus A. So angle FAG can be written as equal to angle B, and this is what we require. This you will be using it where, because in triangle FAG this side and this side are equal. Okay, we will move on to the next part. Now let us see. We have understood FAG is equal to angle B. Now in angle FAG, triangle FAG, I can say FA is equal to AD, and AD I'll directly write is equal to BC. Why? Because FA is equal to AD. FA is equal to AD and AD is equal to BC. These are opposite sides of parallelogram. Opposite sides of parallelogram, that is why they are equal, and FA and AD are equal. FA is equal to AD because these are sides of square. No need to write, but I am just explaining you so that there may not be any confusion. Now FA and AD are equal because these are the sides of the square DEFA. Now these two are equal. At the same time, AD and BC are equal because they are opposite sides of parallelogram. Now this is equal to this and this is equal to this. So FA is equal to BC. That is why it is written FA is equal to BC. Similarly, we can say AG is equal to AB. Reason is sides of square. Which square? ABHG. ABHG. This and this are equal because they are the sides of the square. We know that sides of the square are all equal. Now, next we can say angle FAG is equal to angle B. This we have proved here. FAG, this angle, and this is angle B, because we have proved angle B is 180 minus A, and here also we have proved that FAG is also equal to 180 minus A. So the numerical value of both these angles are equal. So we can say according to side angle side and side angle side, these triangles are congruent. So we can say therefore you can write proved above. Proved above. Where above? Above means all this is the proving of the angles. Now therefore we can say that triangle FAG is congruent to triangle ABC. Now we were supposed to prove FG. This FG is equal to AC. So therefore FG is equal to AC by CPCT, and here you are going to write side angle side. SAS rule. With the help of SAS rule, we have made these triangles congruent, and then FG is equal to AC by CPCT rule. Hence it is proved. So that was the solution or the proving of question number 22B part. Now we move on to the next question. Now next question is question number 23, and that is the last question of the exercise. In this they say ABCD is a rhombus. So I have made a rhombus ABCD. Now what are the properties of rhombus that we are going to use here? The basic property of the rhombus is all its sides are equal. So we will assume that let AB is equal to x. Length of AB is x. If this is x, this will also, BC is also x, CD also x, and AD is also x units long. Now it is given that angle is 60 degrees, so I have marked angle is 60 degree. We have to find the ratio of AC and BD. AC is this and BD is this, so we will join AC. So when we will join AC, it will be AC and BD. Now let us take a point O where these diagonals intersect. We know that in a rhombus, diagonals intersect or bisect them at 90 degrees. So this angle is 90 degree. This also 90, this also 90, this also 90. We'll come to it on, or this point will come later on. Now, it is given that this angle is 60. You can see. So if I talk about triangle ABD. In triangle ABD, triangle ABD will become equilateral triangle. Why? Because I am drawing it separately, something like this. This angle A is given 60 degree and this side are equal. If these two sides are equal, then angles opposite to equal sides will also be equal. Let us say the value of this angle is A, so this also will be A. It means according to angle sum property, we can say 60 plus A is equal to 180. It means 2A is equal to 180 minus 60 is 120, implies that A is equal to 60 degree. It means this angle is 60, this angle is also 60, and this angle is also 60. So we can say that triangle ABD is equilateral. Triangle. If it is an equilateral triangle, it means the length of AB is equal to length of AD is equal to length of BD. This is x, and BD also comes out to be x. We know that the diagonals of rhombus bisect themselves at their intersection point. So if BD is x, so DO will be half of BD and OB will be half of BD. So this comes out to be x by 2. At the same time, this also comes half of x. Now, we can calculate the length of AO in terms of x. How? Because ABO is a right angle triangle. Means in triangle AOB, angle O is equal to 90 degree, it is given. So side opposite to 90 is hypotenuse. It means we can say that according to Pythagoras theorem, hypotenuse square is equal to sum of the squares of other two sides. That is AB square is equal to BO square plus AO square. AB is x, so x square. BO is x upon 2. So x upon 2 square and plus AO square. So this can be written as, or you can say implies that AO square is x square minus x square upon 4. This x square upon 4 comes to this side, will become minus, so x square upon 4, so that is what it is written. LCM will be 4. This will be 4x square minus x square, that comes 3x square upon 4. So AO will be under root of 3x square upon 4, that comes under root 3. This is AO. We calculated AO, so the value of AC will be twice of AO, because we know that the diagonals of the rhombus bisect themselves. So we can say AC will be 2 times of AO, and AO is how much? X upon 2 root 3, or you can say root 3 into x upon 2. This is AO and multiplied by 2. 2 times of AO. AC is 2 times of AO, so 2 times of AO is this. 2 and 2 cancelled, so final value of AC is x under root 3. Similarly, we can find out BD. BD you know is x, because we have already proved that ADB is an equilateral triangle. X, so this total is x. Now we have to find the ratio of ACs to BD. So AC is to BD can be written as AC is x upon root 3 and BD is x and x cancelled out. So we got ratio is root 3 is to 1. That is the ratio between AC and BD. The basic thing in this was to find the length of AC and BD, and we don't have any measurement, but we have this measurement that this angle is 60 degree, and that helped us a lot. So this way we have calculated the ratio of ACs to BD. So with the end of this question, we come to an end of this whole chapter. This year only this much is there in the syllabus, so we have finished off with this chapter. Nothing else is there in the syllabus. Constructions have been deleted for this year. Now next question next chapter that we'll be considering will be circles. So till then, stay blessed, stay tuned, and stay safe at home. And please like, subscribe and share, and also keep on working hard. In case you have any doubt, just send me to this number. Thank you. Have a nice day.